right, so let's get into this. We all know fiber is the future,
Right.
right? But there's this big challenge.
Right. How do you get all that old school CATV signal, the stuff running on coax, onto this new high-capacity glass?
Exactly. And today we're going to do a deep dive on a specific piece of hardware that does just that. It's the Thor broadcast, F-RF-1310-Tx-4mW. It's all about making that RF over fiber, or RFOG, transition actually work.
And it's fascinating because at its core, this device is really just a critical translator.
Translator.
Yeah. It takes that incoming radio frequency signal,
Yeah.
from a coax cable, and it converts it directly into optical RF instantly.
And it handles the whole
A
spectrum.
whole thing. The entire 45 to 870 megahertz band. That means every single one of your channels gets packed onto one single fiber strand.
Okay, that consolidation is obviously key for scaling up. But let's talk about the hardware itself. The sources mention a highly linear DFB laser with a 4 mW optical power output.
Right, which is about plus 6 dBm.
So what does that 4 milliwatt punch, that plus 6 dBm signal, really mean for an operator out in the field? Does that translate to distance, robustness?
It translates directly to confidence in your link budget. That's enough power for long, reliable fiber runs without degrading the signal quality you need. But I think the real efficiency boost here is the automatic gain control, the AGC.
So it manages the levels for you.
It does. It just monitors the input signal and automatically adjusts for any RF level between 11 and 29 dBmV.
So the technician doesn't have to be there with a meter fiddling with manual pads or anything like that?
None of that. It's a huge time saver. And this thing is built for versatility, too. The output is industry standard RFIG.
Which means it'll play nice with other manufacturers' gear.
Yep. You can plug it into pretty much any fiber optic RF receiver. You can use it for a simple point-to-point link, or you can combine it with splitters for those big point-to-multipoint networks. Think college campuses, that sort of thing.
Okay, now let's shift gears a bit, because this is where I thought it got really interesting. The sources talk about an unexpected feature, something they call a high-security fiber break.
Yeah.
Why would you do that? I mean, why go to the trouble of creating a hard fiber separation? Isn't modern signal encryption on coax good enough?
That's a great question, and it really gets to the heart of physical vulnerability. When you force the signal entirely onto fiber and create that complete fiber break, you are you're literally eliminating the coax signal return path.
And that return path is the weak spot.
It's a classic vulnerability in high security environments. It can be tapped, it can leak sensitive data, all of it. So by just shutting down that attack vector entirely, you get a much higher level of physical security than just encrypting a signal on an old copper line.
That's a really critical insight. The value isn't just about speed, it's about actively removing a weak point in the chain.
Exactly.
All right, so let's talk deployment. There's one tiny technical detail here that sounds like it could cause a massive headache if you miss it.
I know exactly which one you mean.
The optical connector. This unit needs an SCO-PC connector, angle polished.
And that little angle, that's the whole so what moment here. It is so important.
Why? What does the angle do?
That angle polish connector is designed to scatter light reflections away from the fiber core. Reflections are poison for your signal. They create noise. They create degradation.
So what happens if your existing fiber run uses a flat connector, like an SCPC or an ST?
Then you absolutely have to use an optical jumper to convert that flat end to an SCO-PC before you plug it in. If you don't, it just won't work right. And I'm telling you, this is probably the single most common failure point people overlook during an install.
I can just imagine the support tickets. It's always the smallest detail, isn't it?
Always.
So to wrap this up, what does this all mean for you, the person listening? We've seen how one device can translate an entire CATV spectrum onto fiber with a solid 4 milliwatt punch.
We talked about the huge security benefit of actually removing that coax return path.
And of course, that crucial detail about needing an angle-polished SCPC connector to avoid killing your signal.
Right. So while this device really does solve the problem of moving old signals onto new fiber, here's the final thought I want to leave you with.
Okay.
Even with this kind of robust performance, specs like carrier-to-noise ratios of over 50 dBs at 10 kilometers, what new engineering challenges do operators now face to maintain that same quality, especially signal flatness, as these fiber networks get longer and more decentralized than ever before? Something for you to ponder.